Hi, we are from Group 2 and today we will presenting our project for the course SBEU 4803 Deformation Survey. So our project title is Laser Lidar using ICESAT-2 and Gedi data, guided by SR Dr. Abdul Wahid bin Rasib. So this project focuses on utilizing space-borne Lidar data from ICESAT-2 and Gedi mission to analyze deformation and surface changes. So this project is prepared by Nur Izzati binti Abdul Hakim, Muhammad Fariduddin bin Muhammad Joel, Nurul Izzati binti Cik Azib, Muhammad Shabil bin Muhammad Shamsuri, and Nur Anatasha binti Nurlam. So we hope you find our presentation informative. Let us begin. This is our group member. The first step is Gedi and ICESAT-2 data extraction using Python. After downloading the Gedi and ICESAT-2 data from the Earth Data website, we proceed with the data extraction process using Python. To do this, we first open our Python software. You may use any IDE of your choice. In this tutorial, we are using PyCharm. If we look at the downloaded Gedi data, there are 9 files provided. For this tutorial, we will select one file and use the copy as path function to obtain its directory. Next, we return to the Python script and update the file path. Specifically, look at line 13. Here we paste the copied path to let the script know where to find the Gedi file. Then, go to line 58. This is where we specify the name for the output file. You can rename it as needed to match your study or area. Once both lines are updated, we can run the script to begin the extraction process. If you look at the bottom section, you can see a module not found error message. This means the required package is not installed yet, so we need to install it first. After successfully installing the required package, rerun the code. As you can see, the elevation data for Gedi points within Johor has been successfully exported. Open the exported file, and as you can see, it contains a lot of data for each Gedi point. And after that, just repeat the same process for the remaining Gedi files. Phase 2 is data cleaning and format conversion. In this phase, we need to edit and reformat the data by converting it from a Microsoft Excel worksheet to CSV format. This step should be repeated for all 9 Gedi files. Next step is coordinate transformation from WGS-84 to GDM 2002 Cassini geocentric. For this step, run GDTF software and click Continue. Then click Peninsula Malaysia and choose 3-dimensional transformation. At the transformation modules, select the right modules. At the input choice, select batch processing, then select the right input format. After that, click Browse and find your files. Choose your output format, then click Browse. In this step, we need to specify the output file path. This is where the extracted data will be saved. Make sure to update the file name and directory as needed. After setting everything, simply click Transform to execute the process. Then, repeat the same steps for the remaining 8 Gedi files. After all 9 Gedi files has been successfully transformed from WGX84 to GDM2000, go to the Submodule section and select Map Projection. Under Input Choice, select Batch Processing, then change the transformation modules from GDM2000 to Cassini Soltner J100. Under the state selection, change it to Johor as our study area is located within the state of Johor. Then, click the right input and output format. After that, click Browse and find your files. Next, update the output file paths in the script. This tells Python where to save the exported data. Make sure the file name and location are correct. Then click Save. After setting everything, simply click Transform to execute the process. Then, repeat the same steps for the remaining 8 Gedi files. The fourth phase is data filtering. In this step, we need to filter the data, as some of the entries may be inaccurate or invalid. So, to clean the dataset, we use Excel to eliminate any elevation values that are above 100 meters. Well, this helps ensure that only reliable data is kept for further analysis. So after filtering the data in Excel, we can see that the elevation values exceeding 100 meters have been clear or left blank. To quickly remove all these empty rows, we will use Python to clean the dataset efficiently. In this step, we begin by generating the Python script that will help us process the clean data. So once the script is ready, we need to update the folder path in the code to ensure it points to the correct location where our filter Excel file is stored. So this allows the script to access and process the data accurately without any error. Once the folder path has been updated, go ahead and run the code. This will automatically process the file and remove any rows that contain empty or missing values. After the script finishes running, a new clean dataset will be generated and saved, ready for the next phase of analysis. This is the filtered Gedi elevation data in Excel format, which has now been cleaned and is ready for further use. So the last step is surface profiling using Civil 3D software. We will begin this step by opening the template file, which will be used as the base for our next process. Next, click on Insert, then select Point from File. Click Add, then find your filtered Gedi elevation data in Excel format. And after that, select your file format, then click Add Point to Point Group. Then after setting all, click OK. Then the data from the Excel file will be displayed on the interface. Then on the left side under Tool Space, click Surface, then choose Create Surface. Then click Definition and choose Point Group and click Add. Here, choose your point group, then click Apply, then OK. On the top of the menu, click on the alignment, then choose Create Alignment Tools. Once all the necessary settings are in place, navigate to the Alignment Layout tools and select Tangent with no curve to draw a straight alignment line. This line will serve as a reference to generate and visualize the surface profile from the surface that we previously created. Once the alignment line is successfully created, click to select the line, then proceed to the Alignment menu and choose Create Surface Profile to generate the profile from the designed surface. Once all settings are configured, identify and select the desired point location to generate the surface profile. And there you have it. The surface profile is successfully generated and displayed. That's all from us. Thank you.